SpaceX recently made headlines with the cancellation of the Starship Flight 8 launch attempt on Monday afternoon. This delay, which took place shortly after Elon Musk provided a specific reason for the issue, was unexpected and caught many by surprise. Let's break down what happened and explore the technical reasons behind the delay, as well as the bigger picture surrounding SpaceX's Starship program. Starship Flight 8 was supposed to replicate the objectives of the previous Flight 7, testing new heat shield technology, deploying Mach Starlink satellite, and validating the Block 2 design. However, during the final moments of the countdown on Monday night, an issue emerged, causing the launch to be aborted. SpaceX has a unique system in place for its Starship launches, different from its smaller Falcon rockets. For Falcon launches, SpaceX has a more limited time window, with a hold only possible after fueling begins. If an issue is identified after T20 minutes, a full abort is triggered, and the launch is cancelled. In contrast, for Starship, the countdown can continue until T40 seconds, and if problems arise, the countdown can be temporarily paused while engineers assess the situation. This flexibility stems from Starship's significantly larger fuel tanks, which have a slower cooling rate compared to Falcon rockets, giving engineers more time to resolve issues. During the Starship Flight 8 countdown, around T25 minutes, SpaceX identified an issue with the booster, which led to a countdown hold. Although the countdown didn't stop entirely, the hold was triggered at T4 seconds as engineers attempted to resolve the problem. After a few minutes, the issue with the booster was resolved, but another problem emerged with Ship 34, which led to an extended hold. SpaceX had the option to hold the countdown for a while, but due to the remaining time in the launch window, about 40 minutes, SpaceX had to make a critical decision. Eventually, SpaceX resumed the countdown, but shortly after, Booster 15 triggered another hold, bringing the countdown back to T40 seconds. At this point, SpaceX had been holding the countdown for nearly 6 minutes, ultimately deciding to abort the launch. Following the decision to abort, SpaceX tweeted that the reason for the delay was related to the booster, though no specific details were provided at that time. Elon Musk later clarified the issue, explaining that there were too many question marks surrounding the flight, with the problem stemming from a pressure being 20 bar too low on the ground spin start. This issue referred to the pressure needed to initiate the turbo pumps of the Raptor engines, which are essential for delivering fuel and oxidizer into the combustion chamber. The term ground spin start indicates that the issue was identified during a pre-launch ground test, not in flight. A bar is a unit of pressure, with 1 bar roughly equal to Earth's atmospheric pressure at sea level. Therefore, a shortfall of 20 bar represented a significant problem, pointing to an issue with the fuel delivery system or the pressurization process. Musk's statement indicated that the issue was related to the ground pressure being too low, and that engineers would inspect both stages of the rocket to resolve the problem before the next launch attempt. He suggested that a delay of a day or two would be enough to inspect and fix the issue. The delay wasn't due to overconfidence and skipping a wet dress rehearsal, nor was it entirely driven by weather conditions, as some had speculated. The delay had a valid technical reason, and SpaceX planned to return within 3 days, with a launch window extending until March 6. Despite the cancellation of Starship Flight 8, the delay does not seem like a significant setback for SpaceX. The company continues to make strides with its Starship program, achieving new milestones that will eventually lead to future successes. One of the most exciting prospects for Starship is its involvement in NASA's Artemis program, which is focused on returning humans to the moon and eventually establishing a permanent lunar base. Starship's role in the Artemis program is crucial, as it will serve as a lunar lander, transporting astronauts to the moon's surface of NASA's Artemis 3 mission, slated for 2026. In recent months, SpaceX and NASA have made significant progress in their collaboration, completing over 200 docking scenarios with Starship hardware at NASA's Johnson Space Center. These tests were designed to validate the docking system for Starship, ensuring that it could reliably dock with NASA's Orion spacecraft in preparation for the Artemis missions. The successful completion of these tests is a critical step toward ensuring that Starship can safely land astronauts on the moon and facilitate future human exploration of deep space. The goal of the Artemis program is to establish a sustainable presence on the lunar surface, particularly at the moon's south pole, where water ice may be present. This water could be used for fuel production and other mission needs, which is why NASA is so keen on ensuring the success of the Starship system. While Starship has not yet completed a successful orbital flight, its lunar docking system is based on the Dragon 2 docking system, which has been used extensively for International Space Station (ISS) missions. This heritage gives Starship's lunar docking system a solid foundation, increasing the likelihood of success. After the Artemis 3 mission, Starship will continue to play a vital role in future lunar missions, as it will also be used for astronaut transfer to NASA's Gateway space station. SpaceX's Starship is not just a lunar lander. It is being designed as a fully reusable interplanetary transport system that can carry humans to Mars. The selection of Starship as a lunar lander by NASA is part of a broader partnership that benefits both parties. NASA gains access to a highly capable and cost-effective lunar lander, while SpaceX gets the financial backing and real-world testing opportunities to continue developing its vehicle for future Mars missions. This collaboration accelerates the development of technologies necessary for deep space exploration, such as propulsion, life support systems, radiation protection, and autonomous operations. Despite the delay of Starship Flight 8, SpaceX continues to push forward with its ambitious plan for the future. The company's long-term goal is to establish a human presence on Mars, and Starship is the key to realizing that vision. With its ability to carry large numbers of passengers and cargo to deep space destinations, Starship will enable humanity's expansion beyond Earth. This vision is not just aspirational, it is actively being pursued by SpaceX, with or without government support. The Artemis program is an essential stepping stone, but it is only part of the larger picture. SpaceX's involvement in the program will ensure that the technologies developed for lunar exploration can also be used for Mars missions. The challenges of lunar and Martian exploration are vastly different, and both require advanced technologies to overcome. While the moon's proximity to Earth makes lunar missions more manageable, Mars presents significant challenges, such as long communication delays, limited launch windows, and the complexities of landing and returning to Earth. These challenges make Mars exploration far more difficult, but they also provide an opportunity to test and refine the technologies that will eventually enable human missions to Mars. The Artemis program, with SpaceX's Starship as a key player, provides a unique opportunity to test the systems needed for both lunar and Martian exploration in real-world conditions. In conclusion, while Starship Flight 8's delay may seem like a setback, it is part of a larger effort to refine and perfect the technologies that will allow humanity to explore the Moon, Mars, and beyond. SpaceX's partnership with NASA in the Artemis program ensures that Starship will be a crucial tool in achieving these ambitious goals. The challenges are significant, but with each test flight and milestone achieved, SpaceX moves one step closer to realizing the vision of making humanity a multiplanetary species.